Okay, so here's my screen. Now that we have the IDE, there's one step that you can take, before we continue. So if you use two fingers to click on practice, there'll be a new file option. So just create a new file and you'll get a prompt to enter the name of the file. So just give that file your name. So for example, I'll go to practice here and use two fingers to click, then I'll hit new file and you have a section to enter your name. So I can say Rishabh. And so just create that new class called Rishabh or with your name. And then we won't be clicking this file, but you can use it on your own if you want to test anything that we're learning at the moment. So yeah, just create your own class like that. And you can switch back and forth between Maine and your name. And you can use that class to test, whatever you want to test. So I'm just Sharifa, Snigdha, and Kashif, just do what I said. And we'll wait till we see your class on the left.
Okay.
Were you able to create it? Sharifa, Snigdha, Kashif, were you able to get it set up?
It shows that I have it, but like when I click somewhere on the screen, it just disappears.
Can you speak a little bit louder? I can't hear you.
I created a new file and I named it as my name, but like when I click it, it just disappears.
Okay, so I can see Sharifa has given hers. Now, again, Snigdha, why don't you just share your screen quickly and show me what you've done? Okay, so Snigdha, and hit enter. Okay, so there's Snigdha, and let's see if it appears here. Yes, Snigdha appeared. Okay, great. And Kashif, I'm not sure if you're here, but if you are, just create that file with your name. Okay, and let's continue. So here's our IDE. This is the Integrated Development Environment, and this is where we'll write our code in this workshop. So let's go back to this slideshow. And this is the next step. We'll just go straight to a whiteboard. So this whiteboard I'll use to explain the concepts of programming and Java. And then we'll go into the IDE and put that into code. So the basis of all code is data. So I'll just write that here. Data and manipulating that data. So manipulating data. So this is the entire basis of code. So, there are many ways you can have data. It's not always just a 1, 2, or 3. You can have, sure, what's the age of a person? Maybe 15. Will it rain today? Yes or no. That yes or no value is a piece of data. What's the name of your math teacher? That's a piece of data. And they're not all, they're not the same type. You have maybe a true or false, yes or no type of data. You have a number, you have, a string of characters, a word. So, there are all types of data. And we need to represent this data in code. So let me just give some examples. Age, this would be represented as an integer, as a number. This is represented as string of characters. Then we have, true or false, the true or false value. This is called a Boolean. Funny word, but it's called a Boolean encode. So, we have these kinds of data. Then we'll manipulate that data. We need to use that data in some way. So if we have our age data, maybe a manipulation would be print how old this person will be in 10 years. So that would be, age plus 10. This is a manipulation of that data, age plus 10. Then maybe we have, return the name of your teacher. So this would be a simple print statement, just print the name. Even that is manipulation. Then we have true or false. If it's raining, then go outside, or rather don't go outside. And if it's not raining, go outside. So, if is raining, then we can go outside. And if not, then don't go outside. So, this is how we'd use, how we'd manipulate the data that we have. So this brings us to the data type concept, which we just covered, but we'll practice this in code. So if I clear my drawings and I stop sharing this, and instead I share the whiteboard, or rather the code, here we are. So within main.java, we'll delete this. And don't worry, what is this class? What is this? Don't worry about that at the moment. We'll cover it soon. But let's start practicing creating values, creating data. So, of course, data is stored in a variable. That variable has a name. So when we create a variable, we need to specify some values before we can give the content of that variable. So first, we'll specify, what is the data type? Well, it's called a data type. What kind of data is it? For example, it could be an int, could be an integer. So if we have an integer value, we put int, and we can use that same age value. And let's say the age of our teacher, or let's say maybe your age of person is 10. Actually, we don't even, this is some silly naming here. We don't need to call age of person. We can simply say age. So then we say equals 10, and then this semicolon here tells the the interpreter, the Java interpreter, that this is the end of one statement. So the thing about Java is you can really format it in any way you want, as long as you follow this base syntax. So we have, again, the type of data, then we give the name of this variable, of this value, then we put equals, a single equals, and then we have the value. And notice, if we put like false here, this is not a valid statement, because we specified this variable must have an integer value, but we've given it a Boolean value. And by the way, I'll put it in the chat how you spell Boolean. That's how we would spell Boolean. So, we've given a Boolean value to a variable which should hold an integer. And, if we were to run this, we'd get an error over here saying that we cannot assign a Boolean to an integer value. See, this is an error. Boolean cannot be converted to integer. So we have to be careful that we don't put wrong values in here. So we'll keep it at 10. Then let's specify a string. So, be careful that we name this with a capital S, not a lowercase s, and I'll explain why that's the case later. And then we have, string name equals, maybe we'll call it Sharifa. So this is Sharifa's name. So remember that when we're creating a string, we specify that it's a string by putting it within these semicolons, within these quotes. If we instead just directly say Sharifa, this is not a valid statement. It doesn't, the interpreter does not understand what this means. So we indicate that this is a string value by putting it within quotes. And then we put the semicolon at the end to show it's the end of the next statement. Then third statement, let's create a Boolean. Boolean is raining equals false. It's not raining at the moment, at least in California, or at least in Fremont, California. So this is, another same format. We, have the data type, that is the Boolean here. Then we have the name, and then we put equals, to show we're assigning a value to that variable, and then we give the value false. And Boolean values, remember, have only two values, two possible values, true or false. So these are three examples of creating variables and assigning values to them. So now we get to some naming conventions. Really, I have just one naming convention, and that is whenever we create a Boolean value, we should always start with the word is or has or will, these kind of words, something that would make sense in this context. I'll talk about these if statements later, but if we were to say if is raining, let me type that properly. If we had a statement like, if we had an if statement like this, as it's called, then this should read like English. If is raining, that makes sense. It's like reading English. We can also call it has cookie. If we can put the same phrase here, has cookie, and this will work. This also reads like English. If has cookie, if this person has a cookie. So we should name our variables, especially the Boolean values, such that when we use it later in context, it reads like English. This will help comprehension of your code. If you instead say raining, maybe raining makes sense. If it's raining, that kind of makes sense. But if you say if is cookie, if cookie, does that really say anything? That doesn't really say anything. Does that mean if does have cookie or does not have cookie? So we should name our variables properly. If is raining. Okay. Oh, all right. So here we have the data types. So now we've covered some, basic data types. And at this point, I'll share my screen to cover a new concept. That is reference types versus primitive types. So if I stop sharing there, instead share a whiteboard again. We have this whiteboard, so let's start. Okay, we have primitive data types. The primitive data types are very simple values. If we say primitive here, make a list. Primitive. We have this primitive types of data, that is the integer, the Boolean. The other types of numbers like floats. I'll explain what float is later. We have these types of values.
Excuse me, your voice is not clear.
Okay. Naman, Dandini, were you two able to hear me till now? Oh, what'd you say?
I said I could hear you.
Okay. Sharifa, since what point were you not able to hear me?
We started from primitive.
Okay, so I'll just repeat from primitive data. So I was talking about there are two types of data. That is the primitive data type and the reference data type. So I'll also write that here. Reference type. So these are the two kinds of data. And primitive data is very simple data. That is the integer, the Boolean, the float. Float is another type of number. So these are the primitive data types. And their principle is there's no behind the scenes references associated with these. So if we were to say A equals 5, B equals A, then A would equal 5 and B would not be a reference to A, but instead it would directly hold the contents of A. So this is analogous to saying B equals 5. So these would hold separate values. So if we were to then reassign A to something else, A equals 6, and then print both of these, B would have the value 5 and A would have the value 6. So that one-time association where we did B equals A keeps just the value of A. It does not point to A itself. So if I were to erase these and then move to the reference data type, I'll show that as well. Okay, here we are. So then reference types have another type of meaning. These are the string, and there's a reason we capitalize the string. the essence string, and that is because it's a reference data type. So, we have the string, then, we also have the integer with a capital I. This is a more advanced version of a normal integer. So these all have capital letters, and they're called a reference type because they don't work so simply like a primitive type. So, if we had created a string called name, string name equals Sharifa, and then we created another string name, string name 2 equals name. Maybe we'll call this name 1 for nice convention. So if we were to say this, and then we were to reassign name 1 equals Naman, then the thing here is name 2 now has the new value Naman as well. The reason being, behind the scenes, this is what happens. We have the name 1 represented in memory. So this is name 1. Shoot, that looks like nothing. This is name 1 here. And we have another box called name 2. So initially, this held the name Sharifa. Name 2, or rather, name 1 held that value. So just assume that this has the value Sharifa. And then name 2 has been assigned to this value. So we don't actually store the contents of name 1 in name 2. We just have a pointer in memory which points to the name 1 box. So name 2 is currently pointing to Sharifa. And then if we were to reassign name 1 to something else, so instead of Sharifa, we put Naman here, then name 2 also contains the word Naman, because this is simply a pointer. Whatever is contained within name 1 is also contained within name 2. They're not two separate entities. Or rather, they are two separate entities, but they point to the same value. So changing one will change the other. All right. So, or rather, changing name 1 will change name 2. So here we are. Let me erase these. So let's go back to the IDE, and I'll show you how that works in application. All right. Also, it looks like Anas has just joined. So Anas, at the moment, we're just covering the basics of Java with this IDE. So let me send you the IDE. Or should I send it to Naman? Okay, here. So just click that, Anas, and you'll be taken to what we're using, the IDE, the integrated development environment. And then if you just click this main.java class down at the left here, you'll see all of our code. So now let me demonstrate what I was saying. So if we had string name 1 equals Sharifa. Then we have string name 2 equals Naman. Then, or rather, name 2 equals name 1. Then if we were to print both of these now, if we say system.out.println name 1, and we print name 2 as well, and we run this code. Okay, looks like we have a small typo here. Let's just fix that quickly. We have one extra thing here. Okay, let's run that. So if we wait for that to run, Sharifa and Sharifa, you can see that now name 2 points to name 1. And that's correct. Now, if we, after associating name 2 with name 1, we reassign name 1 to be equal to Naman. And note, to reassign something, we don't have to put the data type before it. We just give the name and reassign it. So then now if we say name 1 equals Naman, name 2 will also point to Naman because we've reassigned, because they point to each other. So if we wait for this to finish running. Oh, interesting. Name 1 is not pointing to Sharifa. Name 2 is not pointing to Sharifa. Let's see why this is the case. I think this might just be a small bug in this code. We don't really have the time to fix that at the moment, but just remember, that is the concept of object, because some IDs just behave funnily, especially the web ones. So this is just a small error on the ID's part, but just remember that that idea that reference types have behind the scenes references going on, and primitive data types do not have behind the scene references going on. So if we say int a equals 5 and int b equals 4, and then we say a equals b, then now a will have the value 4 as expected. Sorry, let's just put the semicolon. Print a and print b. Okay, so as expected, now both have the values 4. Now, if we were to reassign a to equal 6 now, after we, or rather, if we assign b to equal 6 now, after we assign a to b, now a is still equal to 4, even though b has been reassigned. So if we now run this, b equals 6, I apologize. These colons sometimes are difficult to remember, but now you'll see that a equals 4 and b equals 6. Yes, as expected, a equals 4 and b equals 6. So that is the essence of the primitive versus reference data types. Reference data types have pointers, they don't directly hold values, and primitive data types do directly hold values. There's no pointing associated behind the scenes. And do research that a little bit more if it's confusing at the moment. Okay, so now we've covered these data types, and now we'll move to manipulating this data. So we have some general forms. Actually, before we do this, I'll just ask quickly one random person to, inside this main method, give me answer this prompt. So create Nandini, you should go now. So Nandini, where my cursor is at the moment, create a variable called a and give it the value 10. Then create another variable b and give it the value 5, and then print the sum of a and b. So I know I have not told you how to manipulate data yet, but this is an exercise just to see if you know how to do it. So just create a variable called a, give it value 10, another variable b, give it the value 5, and print the sum. Yes, good. Okay, good. Okay, so good work, Nandini, very close. But the thing here is, first, I'm sure you remember, we need to put that semicolon. And second, I apologize. Looks like there's a car alarm going on outside. Okay, it stopped. I can stay here. So that's correct. You just missed that small semicolon, but this is the erroneous portion here. So first, this is some syntax. It's okay, completely fine if you didn't remember how this works. System.out.println is some Java specific syntax. And then here, when we print the sum of these values, we should not directly ourselves input the sum of the values, because then that defeats the purpose of the statement. We want to find what is the sum. We should not ourselves put the sum in there. So we simply put a plus b, print a plus b, and this will give the sum correctly. So this should return 15 if we look on the right. Again, we need the semicolon. Let's run. Okay, and returns 15 as expected. So very close, Nandini, but just make sure you remember that. We do not put directly the sum inside here. So now we've covered data types. And actually, I've only asked Nandini at this point. So maybe I'll ask Sharifa as well. Sharifa, or maybe Snigdha instead, because I've taught Sharifa before. Snigdha, create a string name, name1, called name1, and give it the value Snigdha. Then create another string called name2 and give it the value Sharifa. So just do those two portions quickly. Okay. Okay, good. Very close. And then now that you've created these two values, print the sum of these two strings. And it might seem weird what I'm saying, but just write the code and then I'll tell you what happens, or you'll see what happens. The word here is print line. And then what would you pass here? Okay, so this is very close, very close. So the first thing here is string and name1 should be separated because string gives the data type of name, and this gives also the data type of the name. So once we create this name variable, later in our code, we should not re-put the, we should not again put the data type. So that data type is only required when we initially create the variable. After that, we can refer to it by only its name. And then you did correctly put the sum value, or rather the sum operator, and we just need to enclose it in parentheses because this is the value that needs to be printed, and that should be enclosed in parentheses in Java syntax. So now if we run this code, we'll see Snigdha Sharifa all in one string. Snigdha Sharifa, as you can see. So the sum of these two strings is just the concatenation of those two strings. That's the word, concatenation of the two strings. I'll simply write that, concatenation. Okay, so this is the word here. All right, so now we've covered these data things, this data type. And now that we've also covered a little bit of data manipulation, we'll move to the hierarchy within code, if you can call it that. So I'll stop sharing this and I'll reshare my whiteboard. And we'll clear all of these. And I'll begin drawing. So within code, we have this hierarchy. The most basic kind of the most basic thing that is contained within a piece of code is the variable. So this is the data that we just talked. The data is contained within our variables. So data is the most basic part of a program. Then a little bit more complex is, or rather, the statements that can be executed on these. So maybe you have the if statement, the loops, these kind of statements. Then those themselves are contained within a function. A method also is another word for the same thing. Our method. Actually, I'll call it function because at the moment, function is the more appropriate term. Function. Then a little bit higher than that is the class. The class contains many functions. So we have the class slightly higher. then, this level of hierarchy is not really, we don't need to worry about it much. But then, we have that within a package. I'm sorry if that writing is a little bit difficult to read. I'm trying to write with my finger. And then we have, the module. The module is the most, for most purposes, it's the most high level structure in code. So if we were to go back to our IDE and show how that works, you'll see. So this is the data portion, the most basic level. String name is Snigdha, string name is Sharifa. And then, maybe you could have an if statement, which I'll talk about here. We have the if, name1 dot equals name2, then print the names are equal. Okay, so this is the second level. This is the manipulation of that data. And then the manipulation of all of this data is then contained within a function. And now this is the function here, the main function or the main method. This is a slightly higher level of architecture. Then we have the most far out level of architecture within a class, and that is the class itself. Where the class is called main. This is the main class, and this is that next level of hierarchy. Then we have this folder here called practice. This is the package which contains all of these values or all of these classes. And then another level above that, which would contain multiple folders, is the package, or rather the module. So we can import modules if we need some external code that's not provided already. And that's the most high level structure. But that's not important at the moment. So I'll show now how to create new methods. So we have a new method. So we need to just as we did with variables, we need to specify some initial values before we create the method. So first we give this keyword public. The public keyword means in another class, maybe if we go to the Naman class, then if we wanted to access this method here, we can access it outside. So if we were to create an instance of this class and then use it in Naman, we can access this method, this functionality of Naman. So, or rather of the main method. So we create public. We can also call it private. And in that case, if we were to instantiate this class, we could not use this method. If we were to use this class in another class, this method would be invisible. We could not use it. But we can call it public so that it's a public method. Then we give the return type. And rather, because this class is a static class, I'll explain what static means slightly later. Static simply means, no matter how many types of, how many instances of this class we create, this method always stays the same. But that's a little bit confusing at the moment, so I'll explain it later. Let's just put the word static in there. And then we'll give the return type. Every method should return something, or it might not return something. And that's what needs to be specified. It can be a void, which means there's a void return type. There's no return type. So we can put void there, or we can put int. Maybe this method will take two values, sum them together and then return that sum. So we can say int. Or maybe it'll take two strings, concatenate them, and then return the concatenated string. So we give string as the return type. That's the kind of thing. Or maybe it'll tell, it'll determine whether it'll rain today. That's the function. And then, in that case, it'll return true or false. And so that's Boolean return type. So let's say we return a string, and then we give the name of the method. The name of the method is, in this case, concatenate strings. And this is another naming convention. When we create a function, we should have a verb. It should read again like English. If we create string name1 and string name2, and I'll explain why what this means just now. But the point here is concatenate strings name1 and name2. That reads like English. If we were to call this method over here, concatenate strings name1, name2, then this reads like English, as I said. Concatenate these two strings. It reads like a sentence. So that's how we should name our methods. The name should be a verb. But we should also make sure it's not overly long. Like we could also short this to concatenate, as you can see. So, that would be a nice name. So now within concatenate, you can see that we have this parentheses portion here. So if we're to delete this, we'll put some parentheses. And at this point, we'd place the input to our method. So the thing here is we don't really know that input yet. We just know it should be something. So we'd actually pass values over here in the client class. That's the name, the client method. So we can say concatenate, and then here we pass the actual name1 and name2. But till this point, we don't really know what those values are. So we can just give the type of data that we need to input, call it a string, and then say, maybe input name 1, and then give another string, input name 2. So here we're stating that we need to input one name, and then we need to input another name. So, that's why up here we have name1 and name2 inputted. And we know that they must be string values. So in this case, if we had another, value called int, int a equals 1, and then we passed a here, that's an erroneous statement because, we expect a string to be passed, but instead we're passing an integer. That's not okay. So name1. So that's the reasoning there, over there. Then now that we have all the input, by the way, these are called parameters. Parameters, the input to to this function, and then we start writing code within the function by putting curly braces and hitting enter. And you'll see that the second curly brace aligns with the back, or with the most left portion of this statement. So just to this portion, I'll ask Nandini, can you create a new method called predict the rain, or predict rain, and it should return a Boolean data type, and it should take no parameters. So just write that code right here where my cursor is. It's a method called predict rain, and it should return a Boolean and take no parameters. And it's a public method. So just start writing that. And if you have a question, just say it. Okay, good, public. What's the next word? Static. Okay, good. And then here we put the return type, that is. Yes, you are right. Just, yes, good. And then we give the name of the method. Predict rain, or predict weather is also okay. Predict weather. Okay, good. And actually, we do want one parameter, and that is our location. So let's create one parameter, a string parameter with the name location. So how would you do that? We'd simply create parentheses. Okay, good. And then create the body. Just create those two braces to begin writing code. Oh no, not there. So just I'll delete that for you. So really at the end we just need this these curly braces here. So it simply hit curly brace and then enter like that. Okay. So great work, Nandini. This is very, very close. So the only two things here are whenever we have a new word, sometimes it's a good idea to capitalize that letter there so that we can easily separate these words when we're reading. And everything else as you did correctly. So great work. And here, we don't have some complex, functionality to incorporate. So we'll just return some value. Let's assume, or rather, actually, I think it was a good idea to keep rain there. So I'll just change that back to rain. Let's just say return true. Return true. So this is the return statement. So, in any function, if the return type is not void, that means if we're returning something, then we use the keyword return. Return means, we're about to return this value from this method. And in this case, we've passed the return value true. So this method will return true. And if we say predict rain, maybe California, or rather Fremont, this is the city where I live, and we say predict rain, then this will return true. And if we print the output of that, through the statement here, and we hit run, and wait for that to run. Okay, looks like we have a small error. Where could that be? Java line 15. Okay, the error here was we didn't return something. So let's just at the moment, just for the for the program to run, we'll just write return hello. Okay, and then let's run again. Okay, so you'll see the Snigdha Sharifa from what we did before, but this second part, true here, is the output of this statement here. So what occurred here is we took a string and passed it to this method. So predict rain is our method, which you've specified over here, which you've created over here. And Fremont is the location. So whatever has been passed into this method is taken to be the value of location. And at the moment, we haven't used our location in any way because we don't have, some complex functionality where, we're not trying to create something so great like Google, like, weather predictions. So at the moment, we're just returning a dummy value that is true. But, really, we should have been using that location and, finding the local weather prediction from, the local website and returning that value, true or false. So, but in this case, we're just returning a dummy value because we don't have that time. Okay, so that is how we create a method. And then, within this method, we can also do some complex functionality. So here, Sharifa, why don't you, within concatenate, write the code that is required to concatenate input name 1 and input name 2, and then return that string. Okay, just write your code in there. Where my cursor is. So just write, create a new variable and, set the value of that variable to be the concatenation of input name 1 and input name 2. So we'd write string. Sharif, are you there? Sharifa? Okay, in that case, it's all right. Naman, why don't you write the code that's required to concatenate input name 1 and input name 2, and then return these two the sum of these two names. Where my cursor is.
I think Sharifa asked to repeat the question.
Oh, she did. Oh, sorry about that. I did not see the chat. Sorry. Okay, so Sharifa, just write the code here. In fact, I'll put it in a quick comment here. Write the code to concatenate input name 1 and input name 2, then return the concatenation. Okay. So this is all that needs to be done. Just write it right below here. So Sharifa, we can just start with the return statement. So we simply hit return. And then within return, what would we return? If you'd like, you can just unmute yourself quickly and just say it out loud, or you can type it.
I'm sorry, here's some power cut and I'm unable to connect with it. I'm sorry, I'm trying once.
Oh, no issue, no issue. Unfortunately, we only have around 3 minutes, Sarifa. So at the moment, I'll just give this task to someone else. But then, if you would like, you can email us later, or we can talk right after, so that we can figure that out. But Snigdha, just write a quick line there to return the sum of input name 1 and input name 2. So just inside return, yes. So okay, it looks like people are slightly okay. Snigdha's typing. Never mind. Keep going. Okay, good. And then how do we end? Okay, good. Great work. So yeah, this is the correct code. So we'd simply write return and then input. We'd return the sum of input name 1 and input name 2. So if we were to use this method here, system.out.println, concatenate name 1, name 2. So if we run this code, wait for it to finish running, then we'll see the exact same result that we saw initially. So we can either directly print the sum of these two names, or we can use the concatenate method to take the input name 1 and input name 2 as input, and return the sum of those two input names. And this was the result. And notice that we can directly just say concatenate name 1 and name 2, but the issue there is we're not printing anything. So even if we run this code, that method won't there will be no error, but there will be no output either. We just have done the operation. So you can see there that this corresponds to this statement here, but after that there's no print statement, even though we have another call. So we need to say system dot out, oh my god, dot out dot println to actually show that value in the terminal here. So that's the operation of this. So we're just about out of time, which is very unfortunate. This is a 1 hour thing, but if you guys can stay slightly a few minutes more, I'll just continue explaining with a few more exercises. So at the very most outside portion, so at the moment we've covered the data types, a little bit of manipulating those data types. We've covered the methods. That is, we can create this method here, that method. And then at this point, we move to the outermost class. So, if we go to this whiteboard here, and, I'll just clear that quickly. Let me just clear everything, clear all drawings. Okay, and now I'll show you how we create classes. So the class is the outermost portion. It contains all of our data manipulations, our functions. It contains all of these. So these classes form the basis of object-oriented programming. And Java is a language through which we can write object-oriented code. So, and the class, as I said, is it's the basic idea of this. So the point of object-oriented programming is we create a class. It doesn't really look like a box, but we can represent it as a box. We can say it has an attribute name. Then it has maybe an attribute behavior, or rather, not an attribute behavior. It has an attribute age. These are all, you know, concrete values associated with this method or with this class. So once we have these two, you know, we can create some behavior as well, some functionality. So you can maybe say, you know, run. If this is an animal class, maybe we'll call it animal. This is an animal class right here. And, you know, we have two attributes, two concrete values associated with this, the name and the age of the animal. Then we know we have some behavior, run, eat, sleep. These are some behaviors that are, you know, attributed to the animal. So if I just, you know, rewrite or just, you know, use another color, this here is the attribute. And this here is the behavior right there. So the, you know, these are just the two formal names for those portions. And this here, you can see it's just a blueprint. You know, we don't have an animal actually created. So, you know, if we were to go, you know, we can go to the IDE and create that class. You know, I've already created the animal class over here. And so we can simply give it some values. I've created the int age, the string name. Then we can create some methods, private void run. And, you know, we don't really have any way to run it, but we can just say system.out.println running. Okay, you know, we can do that. And then we can create another method called eat. Eat, and we can say eating. And, you know, we can say sleep. Sleeping. So these are, you know, this is the structure, a very basic class. So now if we go to our main.java, we can create a new animal. You know, this is just the blueprint here. We don't have really an animal created yet, but these are the characteristics and behavior of an animal. So now in our main class, we can create a new instance or a new animal, a new value animal. So this time we give the data type to be animal. You know, we're creating a new animal, and then we say animal equals, then we say we want to create a new animal and pass it to this variable. So we say equals new animal. This is just the syntax to remember. And then we can say system.out.println. And, you know, maybe we want to get the age of the animal. So we'll say animal dot age. Or actually, before we do that, we have to set the age to something, because at the moment there's no age, it's just empty. So, you know, animal dot age equals 10. Animal dot name equals Harry, or maybe we'll call it elephant. Okay, and then we can print the animal dot age and the animal dot name. Okay, and so you'll see this should work. It's a slightly more complex code, so it'll take a few seconds. Okay, looks like we have a small error here. Animal equals new animal. Okay, so this is just a small issue with this IDE, but in fact, I can share another IDE. This is a slightly different one. I'm not sure if you can see it. Let me just share my screen here. So this is another IDE. It's very simple one. So, you know, if we just go to our main method here and create a new class called animal, it's the exact same thing, by the way. It's just another IDE. Int age, int age, int name. In fact, I can directly copy these values into here. Sometimes these web IDs are a little bit silly, but that's okay. We'll just paste that code directly in here. And then in main, we can go here and say animal equals new animal. And then we can set what we've set over here. So animal.age equals 10. Animal.name equals elephant, and we can do all that. And then run. Maybe I'll just comment this code out real quick. And then we'll run that code. And you'll see that, we've set the name of the animal to be 10, or rather the age to be 10. Then we set the name of the animal to be elephant. And then we print the name of the animal and the age of the animal. And, we get the 10 and elephant. So, this is how we'd create a new animal class. And then we'd, give it some values, give it some attributes, and then, read those attributes and read that behavior. So then if we can say animal dot run. I'm not sure if we added the run. Yeah, yes, we do. Actually, we need to make this public. Actually, we'll make it private. So actually, yes, we need to make it public so that outside classes can access it. Public. Okay. And then over here, we can say animal.run, animal.eat, animal.sleep. And then if we run these methods, we'll see the output of them. We have running, eating, sleeping. So this is how we make use of the attributes and methods of this code. Okay, Anas asks, how are you able to access animal class in Maine without importing? That's a great question, Anas. So the reason we're able to access it in Maine without importing is these are already part of the same package. We'd only have to, import if it's in another module or another package. So here you can see, for example, we have an arrays package right here. This is a different IDE, so it doesn't translate directly. But the idea here is we have an arrays package. Then we have another package called sorting and searching. And in arrays, if we have this class called bingo, and we wanted to access a method, one of these classes like binary search, insertion sort, selection sort, if we wanted to access one of these, then we'd have to say import. And that's, for example, we can say import sorting and searching dot binary search. So that's how we'd import. And at the moment, it's not required. That's why this IDE erases it. We're not using that binary search, so it's redundant. We don't need it, so the IDE deletes it. But really, that's how we'd write that. So the reason Anas is these methods are in the same package, so Java can find that class. But if they were in different packages, then we'd have to import. Is that okay, Anas? Just let me know in the chat. Okay, got it. All right, good. So this is about it for the moment. Unfortunately, this is only 1 hour that we have. But today, what you've learned at this point is how, what are the types of data? How can we create this data in Java? How can we make some manipulations to that data in Java? Then we've covered the next level of hierarchy. That is, the method, how we can, create methods, specify what they do, specify what they return, and then, use them in another method. Then we specified how to make classes. We have a class, we have its contents that are attributes and behavior, and then we can create value. We can create instances of that class in another class, and then, use its attribute, use its behavior, and set its attributes and those things. So at this point, we've ended this workshop. So if you have questions, just ask now. And if you don't have questions, you can leave. Okay. Thank you guys for coming very much. And be sure to participate in the final hackathon after all of these workshops are complete. Okay. Thank you, Nandini. Bye-bye. Okay. See you, Anas. See you, Sharifa. Bye-bye.